And Professor Nguyen and the team, IES team, give opportunity to be here to give the lecture for students. And also that, as you know, just by a year ago, we have a cooperation between the Nong Lam University and National Ecology Institute in Korea. And later on, the Kasan University only joined this project we call the EcoBank project. And but on this idea, we developed the project, get the funding from Vietnam. So today, the project going on is the development of WebGIS based the University Information System for Conservation and Sustainable Management in U Minh Hà National Park, Cà Mau, Vietnam. Actually, the project going on. So we have the two parts present for my presentation. The first part, we're going to talk about climate change, what we're going to do. And the second part, we will talk about the eco-GIS and cloud-based biodiversity database for the U Minh Hà National Park, Vietnam. And so the first one, let's begin with U Minh Hà located in the Mekong Delta. Vietnamese Mekong Delta, so just give you some information concerning with the Vietnamese Mekong Delta. The Mekong Delta contribute, look at the 50% of the country rice production. So most of the rice production in Vietnam come from Mekong Delta, to say. And 95% of the rice exports, 95%. Most of the rice exports come from the Mekong Delta. And 65% for agricultural production. And also the city of the imported fish and 70% the food production. So it's very important, the 1/3 of Vietnam agriculture GDP. So very important Mekong Delta. But we still have problem with the Mekong Delta, which low land with the elevation around 0.3 to the 1.5 meters sea level. And the rice product command then here some. And now we come with the importance of Vietnam Mekong Delta, Mekong Delta. The Vietnam brand just look at it. We can come with the top right product with the Mekong Delta contribute the 95%. And also but we have just give you some information concerned with that. Yeah. And the long-term climate average in the Vietnamese Mekong Delta. So the most rainfall, the bottom recent visit, the higher annual rainfall compared with to the remaining size. And also the ranking the average annual mean the maximum or the minimum temperature compared. Yeah. So that just look at it. We have some station in the Mekong Delta we can. And we come with the multi-temporal trend patterns. We concern with the temperature marks and temperature mean. We're using progressive warnings. We identify the trend. The last measure of the warning trend was statistical significant. And so we have the mode of the term data, so we can get here to around that. Just look at that. We have the 10 rainfall station from in the Mekong Delta. So we're using that. Yet we come with the multiple temperature trend pattern in the Mekong. And also that we can with the sun, now we can with the annual rainfall, extreme indicators, so we can try we accept. If you look at it, we have the beginner and the end here. So look at the curve, just beginning here, then here with all of the station from the Mokwa to Vinh Long, okay, the whole the station in Mekong Delta, and so we found some the increase and decrease for for each point, for each station. And we can get the part and we see in Vietnam Mekong Delta has experienced significant change in the climate, like temperature mean mark and minimum unevent for the dry and wet season, so we can become all of status. And we moderate the climate extreme, even the temporary occurred the several times and at least 1 year for it. That the intensity and region. So we can have a lot of it. And now I come with some very interesting. We are already got the research. As you move around with the climate change, we have two approach. One called the top-down approach, and another one called the bottom-up approach. From the top-down approach, it means the climate change assessment. So the professor from National Ecology Institute just mentioned that we have the top-down approach, and that's the one we call the bottom-up. Bottom-up means the broadly defined term the different with the method are not the top-down. We can indicate the mode of suitable for this method under deep uncertainty that we. Just as the method we can consider what get from the bottom up. And so when we conduct the research concept climate change, we come with the two approach. The one we come with the top down from the global, regional and national scale, and with downscaling we come with the volume solar and district level. And so based on that we come with the localized climate change scenario. This is very important, the Ubana National Park, just only small size in the Mekong Delta. So we need to come with the top-down and bottom-up to come to compare with the localized climate change scenario. So we can very detail the projection to indicate consider one level from the mean, maximum and temperature, minimum temperature for the all emission scenario for the future, and we can be using two scenario, and also for the rainfall also we can. The one that we're using that I already mentioned, we're using from the global climate model and without scaling. From the downscaling we can detail for each province the monitoring station, we can. And so continue with the bottom up approach, and we can combine from the bottom, the top down approach and bottom up approach to support the recent maker to farm. And so we come with the climate change testing for heavy rainfall. What happens if the heavy rainfall? We using the long-term data set from monitoring combined with the global climate model and downscaling, and we can what happened in this side. And also the climate change testing for the ground condition and the flooding and the ground condition at the area. So we can all that we call the scenario neural stress testing approach to adapt the planning in the socio-economic social ecological system. So we can all up. And so some very similar with this from the period presentation. We try to put all of it from that, and so we can. And the second part, the project going on. So we have just finished the first, and it means that we have a very good data set from the climate change scenario. And then now we come with the second part, because with the ecological database. We are very similar with EcoBank. We have cooperation with Korean scientists 5 years ago when we applied the Mekong Delta. And so just that you know about it in you. And the third part, not yet complete, and try to integrate it. So after the presentation, I would like to speak with some scientists from Korea to mention yet what you have done. We still have some challenge when we integrated the climate data with the ecological monitoring. Yet, so I hope you discuss with you later. But you know that the Umina National Park is the and that one can go in the Mekong Delta, and especially in Vietnam, especially Mekong Delta, the most diverse national globally, including for the habitats and so recently the ecosystem to under significant destroyed by the quantity and quality also for it. And the climate change, sea level rise, and the curve for the climate change affecting the ecosystem and also the livelihood. And we start with the cloud-based database and service. So we come with the data information knowledge wisdom model for the digital information. This is the idea we learn from the Eco Bank, and yet we combine with our team. We come with the integrate the information on the biodiversity. And so this research we using with the interdisciplinary research method, which I have many times. With that data I told you with you, the type one try to analyze evaluating the climate. What I have already done. I will show you. And the second one and the third one, okay, we come with social economic, environmental, and the fourth we come with the land and water resource forecasting, and the five for the simulation forecasting biodiversity resource, and we come we see so we come all of that with the type number 8. We propose the model and practical solution, and finally we come with the database. How to digitalization the cloud computing. And so the cloud by the system integrated the server technical method and the functional component such as the virtual server online the database, AI model, IoT and data analytics, effective monitoring, started the data analysis and promote and reaction. So we come with that. And the cloud database integrate to information system, facilitating the storage, visual and administration of the data from the many sources, well enhance the performance, scalability and facility, and design also the integration of the front text and backends provide a help and urge the platform for the spec data application, and also to maintain a balance between the performance and the user experience. So we come with that. We're using from the primary data and the secondary data with the integrating with the GS map, GS and Google Map. So we come with the web app, mobile app to integration. So it's some cloud platform. And we're using the open source for using the open street map, and the interaction map. We find the plan and animal and to all of that. So we can do. I hope get 5 minutes data if you need to make presentation. I will show you in the website. You can test and any comment that we know any feedback. Our team we have been to receive that. We can have all of the quality. And so it also we have all of the times. So that and they have the two versions together with an English, and so you can choose one and to modify. And then also for example, we have we can managing editing and uploading the database for each side to get all of. When we have any picture, okay, we can upload and we can share with your friend and share within the database. That is my thought. I need to 5 minutes for demo to some okay. I just might only that can Okay. If you can put it is okay. We put in the database. So we can. And yet, if you use some satellite data, you can. And yet, here you can control on yet, and we adapted with you yet, using the climate change scenario to put all of it to kind with that. And we try to make very similar with the project that the people from NEI and NEI presentation. The pipeline to support the local government to make the decision. We can do that. And just look at it. And here we have the, for example, but okay, we have on like that, okay. And if you need more information confirm with that, then we show you with the detail, and we can do that. The some of them not, we don't have information, okay, rather yet that we try, okay. And so like this, that, okay. And we have this, and we have the information that below. This idea is very simple, but we need to cooperation with integrating all of the data set. The climate scenario we can with that, and so and we know exactly the location where we find that. Okay, we know exactly and support for the tour and get the tourist also. Okay, who want to see yet, and you just for the location, they can show you the way to go there. And we can with that, we can on get information, animal also, they have on, okay, they have on, and we can with that, we can have any determine with cooperation not between our team with the Nguyen National Park, some researcher there, they support to conduct this research, and all the information come from the researcher from Nguyen National Park. The fish also, they have all of the data set. We can with that, so we can very detailed, and so this is the reason that we did all my talk, and so I hope that any comment, any that let me know, and we will share with the cloud platform. You can access. And any question, okay, or any comment, we have you can come and you put in your feedback, and we're happy to receive any feedback from EAF team. Thank you.
Thank you very much, sir. We have still time, and we can accommodate one question. If you have some clarification or would like to also ask questions or share something, if you have the same time.